So now it's confusing, right? Now it get confusing. But the rule still stands. Okay, one rule still stands. One rule can be broken. What is the rule that can still stand? The member must the member must distribute the entire what? Shear stress or shear flow. That is still valid. The rule that we're going to break is which one? Okay. Yeah, we have to break the rule that the first moment of area is not the what? So we will break the rule. How do you know that it's okay to break the rule? When you're driving, it's a speeding ticket. How about this? This is where you have to think deep. The only way that we can prove that it is valid is we have to take two different approaches. The answer has to be the one. So we are going to take two different approaches. Answer will be and has to be the one. If it's wrong, yeah, I have to go and see the toilet photo. Right, here we go. So we are going to consider. So the first thing we do, we're going to sketch the what? The shear flow. Okay, so the shear flow will do this. Okay. The shear flow will do this. Right? We know that the shear flow will do this. All these dots over here are what? These are all our terminus. Yes or no? Okay. So let's consider the right or the right or left web only. Okay. We are going to consider either the right or the what? The left web only. Okay. Okay. So right and left. Okay. And then this one. So this is our right web. This is our left web. And this is our center web. Okay. So let's consider the right or the left. Okay. So again, Q is equal to what? The width, which is equal to 25. The depth, which is equal to 250. The Y bar is 186.76 minus by 250 divided by 2. So this is equal to 186.76 minus 250 divided by 2 times by 250 times by 25. It's equal to 386 times 10 to the power 3 millimeter power of 3 or 386 times 10 to the power minus 6 meter cube. Let me do it again. 186.76 minus 250 divided by 2 times by 250 times by 25, 386. Okay, so 386 is my answer. Okay. Now, for this case, when you consider one side, the failure is what? The failure is only over here. Yes or no? Because you only consider one plate, the failure is only on one side. Are we clear? Okay. So from here, we can calculate that we have our Q is equal to VQ over I. Okay. So our V is equal to 35 times 10 to the power 3. Our Q is equal to 386 times 10 to the power minus 6. And then divide by I. The I is 0.270236 times 10 to the power minus 3. So this will be equal to 35 power 3 divided by 386 power minus 6 divided by 0.270236 power minus 3 is equal to 335.534. So this is equal to 335.535 times 10 to the power 9 Newton per meter. Let me do it again. 35 power 3 times by 386 power minus 6 divided by 0.270236 power minus 3 is equal to, hey, I got a different value now. You got the same number or no? 35 power 3 times by 386 power minus 6 divided by 0.270236 power minus 3. I get 50 now. I do apologize. So I get 50 times 10 to the power 3 Newton per meter. Okay, 0.270. Yes. Okay. Now, let's now consider the center web region. Okay. Now, for the center web region, you know that is what? Under double shear configuration. Why double shear configuration? If I draw the cross-section view, now if I were to sketch the cross-section view, right? It looks like this, yes or no? Right? So if we were to consider the central web, right? We know that failure will either occur on the left-hand side or the what? Right-hand side. Are we clear? That is why it's what? Double shear. If we just consider the left and right web, it's a what? Single shear. This one is a what? A double shear. So when that's the case, Q will be equal to what? So the width is 25. The depth is 350. This part I have to be careful. So this is equal to 100 plus by 350 divided by 2 minus by 186.76. Okay. So this will be equal to 100 plus by 350 divided by 2 minus by 186.76 times by 25 times by 350. It's equal to 772.1 times 10 to the power 3 millimeter cube, or 772.1 times 10 to the power minus 6 meter cube. And then from here, we find that Q is equal to VQ over I. You have to multiply by 2 because it's what? Divide by 2 because it's double what? Double shear. Are we clear? So when you do this, what we have is the V is 35 times 10 to the power 3. The Q is 772.1 times 10 to the power minus 6. The I is still the same. Can't remember now. 0.270236 times 10 to the power minus 3, and then divide by 2. So the answer, 35 power 3 times 772.1 power minus 6 divided by 270236 power minus 3 divided by 2 is equal to 50 times 10 to the power 3 Newton per meter. Now, when you can cross first when the fastener is below the what? Okay, I can show you. Take it from the top, take it from the bottom, your answer will be, shall be the one. Okay, so this proves what? Our hypothesis is correct. Are we clear? Okay, so this is one of the special case, okay, that you can take, you can cross the first moment of area, can cross the centroid. Let's look at another problem. Let's look at this problem. Okay. Right. So when I'm teaching this problem a few years ago, a few students asked me, why is it done this way? And it's not fair for me to say because I say so. Okay. So let's look at this problem. So the problem over here, again, which is the first moment of area that we're going to take? Okay. Which is the first moment of area you're going to take? So now, we have a force coming here, which is Vy. Okay. And then we know that the region of failure is either here or here. Okay. So we can console this is our flange. This is our right web. And this is our left web. Okay, that is our right web and that's our left web. So the first thing we do, we are going to find our centroid over here. I don't have our centroid information, so we are going to determine the centroid. Okay, I'm going to show you this case again. We apply, whether we apply looking at the flange or the web, the answer will be the what? The same. Okay, so by looking at the centroid again, we have our what? We have our section. Okay, so we have our left web, flange, and then we have our right web. Then we have our width and depth. So the width is 2, the depth is 10. The width is 2, the depth is 10. The width is 10, the depth is what? 4. 20, 20, 40. When you add all this up, it's 80. Then you do the Y bar from the top. Some of you in your term test, I realize that you are using this technique, which is good. Some of you are not. I'm fine with that. And then you have your W, D, Y top. So this will be equal to 100, 100, and this is 80. This is 280. So your Y bar is equal to 280 divided by 80. Okay, so 280. So it's 3.5. Wait, the pen wouldn't write anymore. And you guys are not surprised. So if we were to just consider, okay, if we just to consider the flange, okay, if we just to consider the flange, the Q will be equal to what? The Q will be the width is equal to 10, the depth is equal to 4, the Y bar is 3.5 minus by 4 divided by 2. This is equal to 3.5 minus 2 times 4 times 10. The answer is 60. Okay, let me do again. 3.5 minus 2 times 4 times 10 is 60. If we will consider the right web, Q will be the what? The width is 2, the depth is 10, the Y bar is 3.5 or is equal to 10 divided by 2 minus by 3.5. Okay, so 10 divided by 2 minus 3.5 times 10 times 2, and this is equal to 13-inch cube. But remember, at the flange it is what? Double shear. At the web is a what? So when you put in the formula, Q is equal to what? I know I should not be doing this, but so when you put Q is equal to VQ over I, right? For the flange, Q flange is equal to V over I. You have to have 60 divided by 2. This is equal to what? 30 V over I. For the Q for the web is equal to V over I multiplied by 30. And the answer is exactly the what? The same. Are we clear? So again, we prove our concept both ways and it works. Are we clear? I'll see you guys tomorrow. Thank you.